Or free response question with me. It needs a calculator. If you don't have one, you can also do it on decimals. But I'm going to use our Inspire while we do that. So let me read this for you. Uh, for when t is greater than or equal to 0, a particle moves along the x-axis, so it's horizontal. The velocity of the particle at t is given by this equation. So we're given the velocity, and it gives you a position. So x equals 2, the position is 2 when time equals 4. And then we're going to just answer each one of these questions one at a time. So it says at time t equals 4, what is the particle? Is the particle speeding up or slowing down? So how do we know if a particle is speeding up or slowing down? One has to do with its velocity. So I need to know what the value is of its velocity, but I also need to know the acceleration. And that's because the signs have to match. So just because the velocity is positive doesn't mean it's speeding up. These signs have to match. If they don't match, that means it's slowing down. So you do need your calculator here. I did it already on my calculator. Just to know what I did, I'm going to show you, and you can press pause. The first thing I did on my calculator is I first went in my calculator and I defined it, f1 at x, and I typed it in. That's because every question, for the most part, is going to deal with that function, and I don't want to keep typing that function in. I just want to define it as f1 at x, and then I can just use f1 at x for whatever I need to answer the question. So the first thing I did is that. So if you need a moment, press pause. Can you go into your calculator and define it that way, and then we're going to come back. All right, now that you have defined it that way, step number 1, some of these are already ones that I did before I started the video. So the first thing I did, if you look, is I just want to know what the value of the velocity is at 4. So I'm going to write that down. It's 2.978, which is fine. And the big idea is that the velocity is positive at that. Now for the acceleration, it's the derivative of the velocity. So I did the derivative of the velocity. Notice I didn't type it all in. I just used f1 at x. But then I need to know. Now, do you remember how to get that vertical line? That's when you press Control and equals, and then type in x equals 4, and again, Control Enter. And notice the acceleration is negative. That's negative 1.164. So what do we know about the answer now? Is it speeding up or slowing down? So at t equals 4, the particle is slowing down. Why? Because, and now this is where you can say the velocity at 4 is, oops, wrong arrow, is greater than 0, and the acceleration at 4 is less than 0. And that's it. You've given a reason why it is slowing down. To just say the signs are different isn't very mathematical. But to say the velocity is greater than 0 and the acceleration is less than 0, now you're giving a math reason why it's slowing down. Number 2, and if it's going too fast, press pause. Here we go. Number 2 is not right. It's all number 2. This is 2a, this is 2b. So find the times in the interval when the particle changes direction. So how do we know when the particle changes direction? Which one do I use? Position, velocity, or acceleration? And the answer is it's velocity that tells me what direction it's going. So I'm looking at velocity, and I'm looking at when the velocity is 0, when it's at rest, and then I'm going to see if the sign changes from there. So the first thing I need to do is solve this. I need to know when this is equal to 0, and it's between 0 and 3. So I need to know, could I use my calculator to solve that equation? So I did. I just want to show you what I did. So can you press menu, algebra, press solve, and then type in what I typed in. So I'm solving the equation, the velocity equal to 0, and I'm solving for x. And then beside, I put a domain restriction from 0 to 3. Notice I put an equal under the arrow. I didn't need to do that, honestly, even in the question, but that won't affect the answer at all. So I just need to know I put a domain restriction. Because it is trigonometric, it's periodic, there are multiple answers here. But I just want the answer between 0 and 3, and then Control Enter. And then what did I notice? At what time is the particle at rest? And the answer is 2.707. So at that time, the particle's at rest. So I'm going to do a number line from 0 to 3, and I know 2.707, it's at rest. So what I need to do with my calculator is I need to see if the velocity, what the sign of the velocity is in this interval. So for that, I just picked a number between there, and I picked the number 1. So when you see 1, do you see the answer is positive? I need to know there's a sign change. So for here, when I plugged in, so I plugged in positive 1 into the velocity, it's positive. For the next one, 2.8 I picked. So I needed to pick a number between 2.7 and 3. So 2 point something, 2.8, 2.9. I need to pick a number in that interval. And what did I notice about a number in that interval is that the answer is negative. So what I see is a sign change, and that's what I'm looking for. So the particle changes direction at t equals 2.707. Why? Because the velocity changes from positive to negative. Beautiful. And you give a reason why, and not just say because there's a sign change. What changes? The velocity changes from positive to negative at 2.707. All right, 2C. Find the position of the particle at time t equals 0. So what I'm looking for is the position. If I have velocity, how do I find position? And the answer is you integrate the velocity. So that's what I'm going to do. But I need a starting value if I'm going to find it. And I am given a starting value. So at time equals 4, the starting position is 2. So I'm going to start at 2. But now I'm going to integrate the velocity to know what the increase or decrease is. Now, for this question, we're working backwards. So you're given t equals 4, but I'm going back to 0. So I'm going back in time. Now, the integration is going to take care of that. So I'm still going to add, but my bound is going to go from 4 to 0. And notice like where I'm starting at to where I want to go, that's where the bounds go. Naturally, that's either going to be a positive or negative. The sign will take care of itself when you put it in the calculator. Just to make sure the bounds are correct, because I'm starting at 4 and I'm ending at 0 of what I'm looking for. And then you put in the velocity here. So that's what you're going to put in the calculator. I already did that. You can try and press pause. So type that in. Press pause so you can type it in the same way I did and see if you get the same answer. So that answer is negative 3.815. So at t equals 0, the particle position is negative 3.815. Perfect. All right, one more question. So I'm going to flip this page over. Go from there. 2D. Now, the last question is find the total distance. Now, the other word they could do and use is the word displacement. Now, displacement means that all they care about is where you start and where you end. And it could go back and forth in between. But total distance cares about the distance you went to the right, the distance you went to the left, and it's all added as a positive distance. So how do I find total distance then? Well, you are going to integrate the velocity, but it's important that total distance is the absolute value of that. So this is what it's going to look like. To find the total distance from the first 3 seconds, 0 to 3, it's the absolute value of the derivative, and that's it. So you're going to type it in. You already have that velocity in your calculator. This is what it looks like in mine. Once you see it, you can try press pause when you see it on the calculator. So that's what it looks like. You're integrating from 0 to 3, the velocity, absolute value bars. Remember that the same place that you find integration is where the absolute value bars are too. Type it all in, Control Enter, and you can see the total distance is 5.301. And then write a simple sentence. And then you're done. Excellent job. There is your free response question. This was the actual question used in 2016 for free response, and you get to use your calculator. Mr. G Math, over and out. Until next time.